Hello, 7th graders, and welcome to lesson 12.4, where we're going to learn about making predictions with experimental probability. All right, let's check out example 1. Danae found that the experimental probability of her making a bullseye when throwing darts is 2/10, or 20%. Out of 75 throws, how many bullseyes could she predict she would make? So there's actually two methods we're going to learn here. The first method is we're going to make a proportion. So this is going to be with the fraction probability. So we know it's 2/10. The probability is 2/10 that she makes a bullseye. So we're going to set up the proportion that 2/10, the probability, equals x, the number we're looking for, out of 75. So if she were to make 2 out of 10, how many out of 75 would she make? All right, and then we know how to solve proportions. We did this way back in chapter 4 and then again in chapter 8. We can cross multiply. So we do 2 times 75 equals 10 times x. 2 times 75 equals 10x. 2 times 75 is 150. Divide both sides by 10. That means x equals 15. All right, so method 1 uses the fraction probability. We set up a proportion. The second method is to use the percent. So we know 20% equals 0.2. If we know she's going to make 20% of her shots, of her throws, to know how many she'd make out of 75, we just need to find 20% of 75. So 20% is 0.2. Of means multiply, so 0.2 times 75. Well, we can just enter that in our calculator, and x equals 15. All right, so Danae can predict she will make 15 bullseye throws out of 75. All right, your turn. I want you to pause the video, try number 1 at the bottom here, and then play it back to see if you got it right. All right, a car rental company sells accident insurance to 24% of its customers. Out of 550 customers, how many customers are predicted to purchase insurance? Okay, so I'll show you both methods. Method 1, 24% is 24 out of 100. So then we set that probability equal to a number out of 550. And then we cross multiply. And 24 times 550 is 13,200. So that's equal to 100x. So then if we divide both sides by 100, we get x equals 132. So how many customers are predicted to purchase insurance? 132. Now, most of you probably use the second method to solve this since it's a percent. I know 24% is equal to 0.24. So then we just have to multiply 0.24 times 550. And we also get 132. So 132 people. All right, next we're going to look at using experimental probability to make a qualitative prediction. Qualitative means that it's something without numbers. It's non-numerical. So how we're going to see that with probability is it will probably give us a number and then say, is this reasonable? Or explain which outcome or what event is most likely. So we're just predicting likeliness of events and assessing whether or not it's reasonable. So let's check out this example. A doctor's office records data and concludes that, on average, 11% of patients call to reschedule their appointments per week. I'm going to highlight that. That seems like some pretty important information. The office manager predicts that 23 appointments will be rescheduled, so 23, out of 240 total appointments during next week. Explain whether the prediction is reasonable. So to explain whether it's reasonable, we can actually find the probability and compare. So let's find the probability. Method 1 is to use the proportion. So we set up 11 over 100 equals x over 240. 11 over 100 is 11%. Remember, percents are fractions over 100. So then we cross multiply. So we have 11 times 240 equals 100 times x. 11 times 240 is 2,640. So that equals 100x. If we divide both sides by 100, we get x equals 26.4. All right, so using that probability, we could predict that 26.4, or just 26 appointments will be called to reschedule in that week. So then we compare 26 to 23, and it seems 23 might be a little low, but it's pretty accurate. 23 is pretty close to 26, especially out of 240. It's 3 off. It's pretty close. A little low, but pretty close. Another way we could have found the number to expect to be called to reschedule is by using the percent equation. So we know 11% is equal to 0.11 or 0.11, 11 hundredths. So we multiply 0.11 times 240 to find 11% of 240. We also get 26.4. So 2 methods, same answer. You only have to do one. I'm just showing you both. And they come to the same conclusion that the prediction of 23 is reasonable, a little low, because 23 is a little less than 26.4, but it makes sense. Okay, and then let's reflect on this for a second. Does 26.4 make sense for the number of patients? Well, can you have 0.4 of a patient? No. We would round to 26. You can't have 0.4 of a patient. All right, I want you guys to pause the video, try this one on your own, play it back to see if you got it right. All right, in emails to monthly readers of a newsletter, 3% of the emails come back undelivered. The editor predicts that if he sends out 12,372 emails, he will receive 437 notices for undelivered mail. Do you agree with his prediction? All right, so we're going to use the probability of 3% and then the numbers given to see if 437 compares to 3% of 12,372. Now these numbers are a little bigger, so method 1 probably doesn't make sense here. You could still use it. I'm going to show you how to use the percent equation. So first we are going to find 3% of 12,372. And if I enter that into my calculator, I get 371.16. We'll just round down to 371. So 371 is 3% of the total emails sent out. So according to the probability, 3% will come back undelivered. It's probable that 371 come back undelivered. So he predicts 437. I think that's a little high. That's 66 emails higher than what the probability tells us. So when it says, do you agree with his prediction? I'm going to say no. 3% of 12,372 is 371, which is much lower than 437. The prediction is high. The probability tells us it's actually lower. All right, in our last example, we're going to look at using experimental probability to make a quantitative prediction. We've actually already been doing this in our other examples, so let's just do another example. Example 3, an online poll for a movie site shows its polling results for a new movie. If a newspaper surveys 150 people leaving the movie, how many people can it predict will like the movie based on online poll? Is the movie site's claim accurate if the newspaper has 104 people say they like the movie? All right, so some important side facts here. This looks like it is the online movie poll, and 72% of people said they liked the movie. So the newspaper, totally different poll, surveys 150 people. We want to know how many people will like the movie. According to our online poll, 72% should like the movie. So to predict how many people will like the movie, we're going to find 72% of 150 people. So we could set up a proportion. The textbook shows you how to do that nicely here. I will show you the percent equation again because I think it's easier. So 72% is equal to 0.72. If we want to find 72% of 150 people, we need to multiply. Of means multiply, important thing to have in your notes. So 0.72 times 150, we'll just enter that into a calculator. And we get 108. So yes, you could set up the proportion 72 over 100 equals x over 150, cross multiply. That would be 72 times 150 equals 100x. Divide both sides by 100, you should get 108. So the newspaper can predict, highlight this again, 108 out of 150 people will say they like the movie based on the online poll. So there was a second part of this question. Is the movie site's claim accurate if the newspaper has 104 people say they like the movie? Since 108 is pretty close to 104, the newspaper survey and online poll show about the same percent of people like the movie. So yes, it is accurate. All right, your turn. I want you to pause the video, try this one on your own, play it back to see if you got it right. On average, 24% of customers who buy shoes in a particular store buy 2 or more pairs. One weekend, 350 customers purchase shoes. How many can be predicted to buy 2 or more pairs? If 107 customers buy more than 2 pairs, did more customers than normal buy 2 or more pairs? Okay, so first we're going to use 24% and 350 to find the number we can predict. So 24% is the same thing as 0.24 of means multiply, 0.24 times 350. We'll enter that in a calculator and we get 84. So we can predict that 84 people are going to buy 2 or more pairs. So then the second part of the question says if 107 people buy more than 2 pairs, did more customers than normal buy 2 or more pairs? That's yes, more people than normal bought more than 2 pairs because 107 is greater than 84. So this is our predicted number. And then 107 is the number that actually happened. So yes, that weekend, more customers than normal bought more than 2 pairs. All right, your homework today is just the notes video, but make sure you tune into the Google Meets to get some helpful tips. And these 6 problems will probably be assigned at some point, so tune in the Google Meets to know that as well.